Sarah Barden.
And this is our robot, Color Coder.
So our robot is coded in real time via giving it different color blocks. So when it sees red, it moves backwards. When it sees blue, it will turn 90 degrees. And when it sees yellow, it will spin around a lot. And then if you give it black, it will stop where it is. When it doesn't see one of these, it will move forward a little bit to find a new color. Additional functionality could be added to green, cyan, or magenta.
The hardware components for our project include the main drive chassis, 2 continuous rotation servos, 1 for each wheel, a caster wheel on the front, the battery pack, freedom board, Pi Pico, and color sensor mounted underneath one of the wheels. The battery pack goes to the power distribution board, which powers each individual servo, and the freedom board and the Pi Pico. The freedom board has a control wire for each servo and a communication line over UART to the Pico. The Pico then is connected to the color sensor via I2C. The color detection system starts with the freedom board sending the character A to the Pico via UART. The Pico then negotiates with the color sensor over I2C to see what color is currently under the robot. The Pico now has red, green, and blue stored as a 32-bit value for each color, but the UART can only send 8-bit values at a time, so it splits these into 4 packets for each color and sends them all serially back to the freedom board. The freedom board recombines these into a 32-bit value and stores that as the current reading. The first time it takes a reading, it assumes that it's over white for calibration purposes and stores these as the maximum values it should ever see. Then each subsequent reading gets run through the calibrate function that divides by these stored maximums to give us a value from 0 to 1. Finally, we threshold these values where if it's greater than or less than 0.5 for each value, that tells us what color is actually seen. If all of the values are less than 0.5, we know that's black. If they're all greater than 0.5, that means it's white. If you have red and green present, that means you have yellow. Similarly, magenta and cyan can be calculated along with pure red, green, and blue. Finally, this character representing the actual color is sent to the buffer.
So this is for handling what should we do with our actual actions. So first of all, if we see black, we don't want to go anywhere, so we're just going to delay because by default, the robot does not move. Otherwise, we're going to try and push the color into the buffer. If the color is not a new color, we immediately return because we don't want to repeat actions if we're just hanging out on one color. Otherwise, we're going to change what the last color seen was and check, is this a valid command? If it's not a valid command, we also return so it's not taking up space in the buffer. If it is actually a valid command and it's a new one, we're going to add it to the buffer and go back. So if there's something in the buffer, we get to actually do the action. But otherwise, we want to get something, so we're going to have it move forward a little bit in hopes it sees a new color. Otherwise, we're getting the action, and we're going to pop it out of the buffer and send it over to the handler. The handler will use a switch to determine which function this is. So example, if it gets red, it'll do the red function, which makes it move backwards. So for backwards, it reverses, delays, and starts. When reversing, this is what we want the servos to see. It'll see high for a little bit on left and for a little bit longer on right, and that's what the pit timer is for. So in the pit timer, every 10 microseconds, it's going to check, oh, is it time to set it to low or high? If it is the start of a new cycle, we set it to high. Otherwise, if the width has been met for left, the left goes low. If the width has been met for the right, right goes low. Time increases. Once we hit 2000, it has been 20 milliseconds, the interval is over, and we reset time to 0.